Hey, sixth grade. How's it going? Today is Thursday, August 20th, 2020. Hopefully you guys are doing well. Today we're going to be talking about, in conversation, a mathematical concept, which works out pretty good since I'm your math teacher as well. I think that it's really important that we try to find cross-curricular activities and find activities that don't necessarily have to be in the book, but relate more to real life. So that's why, for today's class, even though the topics that we're seeing in the book on page 42 and 43 have to do with shapes, specifically 3D shapes compared to 2D shapes, and also finding a 3D shape from a net, I decided to pick a topic that's more related to real life. Okay, so we're going to be talking about this topic, but we're going to be kind of expanding it in more of a real life way. The first question that I have on the board has to do with 3D shapes, okay? And whether or not you recognize 3D shapes in graphic design, video games, and even movies. So the question says, how have images seen in video games or scenes of movies improved over the years? Well, let's take a look at this. This quote was from an article that I read dealing with this topic. It says, as the years progress, we've seen an increase in the level of detail from early 3D games to those of today. Simply compare the visual detail in a game such as id's Quake from 1996 with the detail seen in Epic's Gear of War in 2006, just a decade later. Then fast forward to a game such as Call of Duty Advanced Warfare in 2014, which saw even enough detail to render recognizable actors such as Kevin Spacey. So we've gone from very little detail in video games to a whole lot of detail. Let me give you one example. The picture that you see on the screen has an image of a video game that was very popular back in the 70s, 80s, early video game times, right? It says, for the Ultima Underworld games, the payoff for this level of 3D quality was poor performance and a small viewing window. That's obviously someone's opinion, but you can definitely notice that the quality of this video game is not as high as the quality of video games that you see nowadays, right? Some of the students were recognizing that these images are very pixeled and they're also very blurry. Okay, we're going to talk about how this relates to 2D and 3D shapes. Take a look at the next picture. Would you say that this video game has bad graphics or good graphics? Take a look at the details within the image. Can you see most of the things that are represented? Now take a look at this image. This video game was called Battle Zone and was thought to be so realistic that the US Army actually used it to train its soldiers. You can see the very clear pictures of two-dimensional shapes such as triangles, squares, and other shapes to create what is known as a 3D model. Now if we take a look at this image right here from a very popular video game on the internet, you can also recognize that there are certain 3D shapes inside of the image. Can you find the cylinder, cube, cuboid, rectangular prism, or any other three-dimensional shapes? Now let's go to another activity that has you guessing which 3D movie was created. To find the answers, you can use the link that's in the notes section of this video. I'll tell you a couple of answers. First one, what movie is this? Correct, How to Train Your Dragon. This is one of very popular movies back in 2014. This movie used 3D graphics in order to display images on the screen. What movie is this? Correct, Hulk, or it could be the Avengers, right? I don't remember the name of this movie, but it also uses 3D images in order to show a very clear, crisp view of the picture of the video. What about this one? Yep, you got it. Up. Very popular. Next one? Yeah, Toy Story. Toy Story's been around for a very long time. When I was a kid, the first Toy Story movie came out, and in 2014, another Toy Story movie came out. So you can even compare the graphics from one of those years, those early years, to current nowadays graphics. What we're going to do now is we're going to play a game just to kind of understand the use of 3D objects in maybe a profession like engineering or architecture. The link for this game is going to be inside of the notes section of the video. And the game goes as follows. What you're supposed to do is you're supposed to count the number of cubes that is on the on the left, and then you're supposed to click the number on the right. Now, we already played levels 1 through 9 in class, so this level is the most difficult. Let me see if I can get it. Let's see, 1, 2, 3, 4 on the base, 5, 6, 7, 8, 9, 10, 11, 12, 13, 17, 18, 19, 20, 20. There's at least 21, maybe 22, 23. I'm going to guess 23. I'm really not sure. Okay, you got it pretty good. Game ended. All right. So again, you can play this game. It's going to be in the links, the notes section on the below, one of the links there. You can also understand that three-dimensional shapes can be made easily with paper and other materials that you have in class. Today we watched this video, which is entitled Make 3D Shapes Using Paper. Now, making 3D shapes is pretty easy. All you need to do is find a net, which you can print easily offline, and pick whichever shape you want. So for example, if you wanted to make a cube or a cylinder or a pyramid, you could find those nets online to try to make those shapes. Okay, we're going to watch very quickly the woman making a shape, which in this case is going to be an 8-sided shape.
When we listen, we forget. When we see, we remember. And when we do, we learn. Dear students, today we are going to learn to make 3D models of solid objects using their 2D nets. What do we mean by 2D nets? A 2D net of a model is a pattern on a paper which can be folded to make the 3D model. Here we have with us various nets of 2D models. This is a 2D net of pentagonal prism. You can fold this net and make its 3D model. Here we have with us a 2D net of square pyramid. You can fold this net and make its 3D model. Similarly, you can see we have placed here various 2D patterns on the piece of paper which can be folded and the 3D models can be made. Today, we are going to learn to make a model of a regular octahedron. Dear students, do you know what is a regular octahedron? A regular octahedron is a polyhedron which is made out of 8 equilateral triangular faces. This is the model of a regular octahedron.
All right, we're not going to watch the entire video, but I'm going to put the link inside of the notes section on the bottom, and you're going to be able to see how to make that shape. I'm going to kind of advance it a little bit. You can see that she cut the net out, and then she was able to fold the different parts of the net in order to create the edges of the net. Later on, what she's doing is making flaps, and then those flaps are going to be put inward, which will later be taped so that the solid figure is more sturdy. Okay, so here she has the end result of the polyhedron. Okay, and it shows that there are 8 sides to the shape. Later on, we're going to be talking about different types of shapes, whether it would be a cuboid, a triangular prism, or a tetrahedroid, spheres, cylinders, and cones. We'll be talking about that not only in conversation, but also in math class. Now, if you have a chance to make one of these prisms or pyramids or any other polygon, please bring it to class. Today we had Carlos bring one of his examples to class. It was a cube, and we had some really interesting shapes that one of the classes had brought, cylinders and other shapes. So nice job today, boys and girls. Apart from the game that we played and the video that we watched, We also were able to watch a quick brain pop video about polygons in general. This brain pop video showed us different characteristics of polygons, showed us irregular and regular polygons, and told us what polygons were and what polygons weren't. It's important that we understand the idea of what a polygon is so that we can take this concept a little bit further and understand it even better. Let's see if we can do a little quiz based on the video that we watched in Brain Pop. The first question says, a polygon is composed of 3 or more line segments. What is another term for line segments? Well, the line segments inside each one of the polygons is actually a side, if I'm not mistaken. Okay, those lines are the same thing as the word side. Number 2 says, which of the following shapes is a polygon? Well, a polygon, like we know, is a shape with flat sides, that are connected by a vertice. Letter A doesn't have any vertices, and neither does letter C. Letter B has some vertices, but they're not straight sides, so it must be letter D. I think that was a pentagon. All right, number 3 says, which of the following is a true statement about polygons? Each line segment intersects exactly 2 other line segments. It's possible. Each line segment intersects at least 2 other line segments. All right. Each line segment intersects exactly 1 other line segment. And each line segment intersects at least 1 other line segment. So the difference between these questions are the number of line segments and also the word exactly or at least. I think it is at least, and I think it's just 1 line segment. So I'm going to click letter D. Oh, that's not correct. What about letter C? Oh man, this is more difficult than I thought it was going to be. Each line segment intersects exactly 2 other line segments. Okay, so when in doubt, pick the first one, right? What about number 4? Why isn't a circle considered a polygon? Well, like we said before, a circle doesn't have any line segments. They're kind of circular, right? They're not straight line segments. So I think letter C is the correct answer. All right. Number 5. Every vertex forms a... Well, if we look at the inside, that would be an angle. And a line segment is not formed by vertices. A line segment forms vertices. So I think it's actually angle. Okay, good. What can you infer about a polygon from its name? Well, it's not area. The number of line segments it makes up, possibly. The sum of its interior angles, no. The length of the perimeter, no. I think it's letter C. The number of line segments that it makes up. Okay, good. So like a triangle would be 3 lines, or a pentagon would have 5 lines. So those words, those prefixes tell us what it is. The following figure is well, let's look at the number of sides. 1, 2, 3, 4, 5, 6, 7, 8 sides. So it must be an octagon. Number 8. Which of the following is a regular polygon? Remember that regular polygons have the same length of sides all the way around and the same length of angles all the way around. So A doesn't, even though it looks relatively regular, it doesn't. C and D are completely irregular, so I think B is the only one. All right, we have 2 more questions. Regular polygons have sides and angles that are congruent. What is the best synonym for congruent? Well, remember that congruent all means equal. So a square has congruent sides because they're all the same length. Number 10. Which of the following polygons is always regular? Well, that's a good question. I don't think it's a rectangle because that has at least two different lengths of sides. A triangle could also have different lengths of sides. A hexagon, I believe so as well. I think the square is the only one. We got it. All right. We got 9 out of 10. That was pretty good. All right, nice job today, boys and girls. Today we were able to look at 3D dimensions within movies and video games. We were also able to understand polygons a little bit better, discuss the number of three-dimensional shapes within a larger construct, and we were also able to discuss the different characteristics of polygons as well as name polygons in nature and all around us. So thanks for coming to class, and we will see you next time.